Hello and welcome to SQA Higher Maths Applications of Differential Calculus. What is calculus again? That is just the name for integration and differentiation, that branch of mathematics. So today we're going to look at the geometric interpretation of integration. So quick recap. If we're integrating 4 minus x squared from 0 to 2, we add 1 to the power, divide by the new power. So if we integrate 4, we'd get 4x. If we integrate x squared, add 1 to the power, that will be x cubed divided by that new power, so x cubed divided by 3, or 1/3 of x cubed. And then how do we evaluate that? Notice the square brackets here because we have definite limits, so we need the square brackets around it. That's the notation we use, and also the 0 and the 2 here. And the next step, as you guys all know, is to substitute in the 2, so 4 2s are 8. 1/3 multiplied by 2 cubed would be 1/3 multiplied by 8, which is 8/3. And then when we substitute 0 into both of these terms, we just get 0. And 8 wholes minus 8/3 is 24/3 minus 8/3, which is 16/3, or 5 wholes and 1/3. So that's a very quick recap on how to integrate a very basic function. Remember, we covered this in chapter 11 from the textbook in the previous integration playlist. So if you've not done all of those questions, you need to go back and do them, guys, before you do this. Okay, make sure you do those questions first. Right, so when we integrate, what are we actually finding out? So if we have a look at the graph of y equals 4 minus x squared, so we have a concave down parabola there because we have a minus x squared term, so concave down, or sad face parabola if you like. Okay, if we integrate this between 0 and 2, what we are finding is the area bound between the curve and the x-axis. So from 0 to 2, so we would be finding out the shaded area. Okay, and we know from above that if we integrate 4 minus x squared between 0 and 2, we're going to end up with 5 1/3. So therefore the shaded area is 5 1/3 square units. So in general, the area enclosed by the graph y equals f of x and the x-axis between x equals a and x equals b is given by the integral from a to b of f of x dx. So basically, when you're doing your integration, you're finding the area between the curve and the x-axis between those two values of x. Okay, let's have a look at another example. So the graph y equals x squared minus 4x is shown below. So a concave up parabola, because we have a positive coefficient of x squared, we have a positive amount of x squareds. Calculate the shaded area. So looking at the x coordinates here for the shaded area, we're starting at 4, ending at 5. Notice we don't need the y coordinate. So it'll be the integral from 4 to 5 of x squared minus 4x dx. So add 1 to the power, divide by the new power. Remember, square brackets and the upper and lower limit written at the end of those square brackets. So add 1 to the power, divide by the new power, so it'll be x cubed divided by 3, or 1/3 x cubed if you prefer. Integrate 4x, we'll get 4x squared divided by 2, which is just 2x squared. And then what do we do next? We substitute in the upper limit, so substitute in 5, and substitute in the lower limit, and subtract those from each other. So we're going to end up with 125 over 3 minus 50 in the first bracket, minus 64/3 minus 32 in the second bracket. Right, guys, do yourself a favor, evaluate the inside of each bracket first. If you just try and basically expand the brackets and tidy up, what you'll find is here we're meant to subtract the minus 32. You guys will all subtract 64/3, then a few of you at least, not on purpose, but will then just write minus 32. But we're subtracting minus 32. Okay, so basically it's prone to error. Don't do it that way. You might make a mistake. You might throw away silly marks in any sort of test that you do in the future. Okay, so evaluate both brackets and tidy up and get 7/3 square units, which is the area bound between the curve and the x-axis.